Everybody, welcome to another video tutorial from linuxhin.com. In today's video, we are going to discuss multi-threading in C, okay? So in order to understand multi-threading in C, first of all, we have to know what is a thread, and then we can basically understand what is multi-threading, and then we will discuss using a few examples that how we can implement that in C, okay? So what is a thread? A thread is basically, it is a single sequence stream within a process, okay? So because threads have some of the properties of processes, they are sometimes also called as lightweight processes as well, okay? So you can ask that what is the basic difference between process and a thread? So the idea is that threads are not independent of one another, but the processes are, okay? Processes are independent and they are not usually dependent on each other, while the threads, they are dependent on each other, okay? So as a result, threads shares with other threads their code section, data section, their resources, the other stuff, but processes, they don't have to share anything, okay? So you can ask that what is the purpose of multi-threading then? So multi-threading basically, if threading is basically having a thread or a single sequence of stream, then the multi-threading, it means that you're having a multiple sequence of the streams, okay? So threads basically, so multi-threading, if you talk about threads, are a popular way to improve application through parallelism, okay? So for example, if you have a browser and you're using multiple tabs in it, you know, those different tabs, they could be threads, okay? So that is the example of multi-threading, okay? So the threads, they basically operate way faster than the processes due to a few of the reasons, and one of them is that thread creation is much faster, and the context switching between threads is much faster. Threads, they can be terminated very easily, but the processes, it may take a while to terminate them completely. And obviously, communication between threads is way faster than it is between the processes, okay? So the next question that you could ask, that if you could write a multi-threading program, or you can implement multi-threading in C or not, okay? So unlike Java, if we talk about, then multi-threading, it is not supported by the language's standard, okay? So P threads, or you can say POSIX threads, they are basically a standard for threads, okay? So implementation of this P thread or POSIX thread, you can do that using the GCC compiler that we have in our Ubuntu Linux. So now what we're going to do is that we're going to write a simple small program that in which we would use this P thread or POSIX thread, okay? So first of all, we have to have a simple text file, okay? And we could save it by the name, whatever name we want. And we can also actually save them using the with the extension .c, okay? So now what we're gonna do is that we're gonna write code here. So we'll write here hash include, okay? And then after that, we're gonna write here stdio.h, and after that, we're also going to write here stdlib.h, okay? These are basically the header files, okay? So in order to use multi-threading, we have to have 4 header files here, okay? So the other header file that we're gonna use is this one is for the sleep function, okay? So we're gonna write here uni std.h, and if we if we want to save it, we can also do that. So let's say if we want to save it on our desktop, so what we would do would just simply write here the file name, let's call it thread.c, okay? So thread.c would be a program. So now you can see that the color, it has been changed, so it is a C file now. All right, so now inside here, the last but not the least header file that we need, in case you don't know what a header file is, it's similar to a library in other programming languages. So these header files, they contain those built-in functions that you would use. So it means that you don't have to write the code all over again. Rather, you would just use the function or the methods, you would call them, and then you would get the result. All right, so what we are going to do here is we're going to go to the next line. In fact, first of all, we're going to write here pthread.h, and now we're going to go to the next line, and we are going to write here. Now we are going to have a normal C function here, which would be executed as a thread when we'll use the built-in pthread create function. Okay, so first of all, we're gonna write here void, and then we're gonna write here the function. So we'll write here static function, and then inside of it we are going to pass a variable. So we can call it, like, let's say static, the pointer, and then we can call it, like, let's say var, the variable, or something like that. Okay, and then we can basically have here a sleep function inside here. So let's say that we want it to sleep for, let's say, for 2 seconds, and we just simply write here a semicolon to end the line, because this is a syntax in C, and if you don't do it, then it would basically give you an error. So you have to have a semicolon here. Okay, so after that, what I'm going to do is that I'm going to have a print function here, which is essentially printf, and inside of the printf I am going to pass through something. So let's say I write here we are using thread. Okay, so we can say that, and then after that what we're going to do is that we are going to return something. Let's say we return null. Okay, so that is it for this function. So now what we're going to do is that we are going to go into our main function that we that is essentially the function which only gets executed. Okay, so what we are going to do is that we are going to write here int main. Okay, so you can write lines and lines and lines of code, and if you don't have a main function, your program won't be executed, and it would not be able to show you any results. Okay, so make sure that you have a main function or main block in your code so that you can have your output. Okay, you can have the execution performed here. Okay, so now what we are going to do is that first of all we are going to create a simple variable by using a data type of pthread. Okay, so we write here pthread underscore t, and then we want to have here the thread ID, so we'd call it t underscore ID, and then we can have here a print function in order to differentiate the the condition before using the threading and after using the threading. Okay, so what we can do is that we can write here before using threading. Okay, and of course when you're basically dealing in C, in order not to show the output on the same line, what you can do is that you can write here /n. Okay, and in a similar way you can have here a /n here as well. You can put a semicolon to end the line, and after that you can basically use the pthread create function to basically create a thread, and from that thread you're going to pass couple of the arguments. Okay, 4 arguments in total. So let's see how to do that. So what you would do, you would write here pthread underscore create. Okay, and then you would have brackets here, and in these brackets what you're gonna do is that you're gonna write here the t underscore id, ampersand, basically it would point to the address of it. Then you put a comma here, and after that you basically write here null, okay, and then you put a comma here again, and now you basically write the name of the function, which is essentially func, and after that you write here null as well, okay. So now you put a semicolon here. We are all done. We're all done in terms of this function, creating this function basically, but in terms of code, we are not done yet. We have to have other things here as well. So now what we want to do, that we want to use the pthread join function, okay. So now I would write here pthread underscore join, and then inside of here in the brackets I'm gonna pass two arguments actually. The one is gonna be directly the ID, the thread ID, and the other argument I'm gonna keep it as null. So now I put a semicolon here, and after that I just simply put in here a print statement. In C you write it as printf, and I write here after thread, okay. So I write here /n actually for the line to go to the next line. Then we go ahead, put a semicolon, and in every C program you have to write this exit 0, exit 1. They basically both of them are same, or you can write here get ch function as well, okay. So now we basically save it, and if we talk about, that we have declared this function here, right here, and inside the main function we have declared a variable which is called as t underscore id. The type of this variable is pthread underscore t, which is an integer used to identify the thread in the system, okay. So after declaring the TID, we have called pthread underscore create function. Basically this function is used to create a thread, okay. So it takes 4 arguments, all right. The first argument is a pointer to the thread ID or TID, okay. It is a pointer. And the second argument, it specifies the attributes which we have kept null actually, all right. And if we have kept it null, then the default attributes would be used. So if we talk about the third argument, this is the function that we have created which needs to be executed, so we have called it. And the last argument, but not the least, is the fourth argument, which is used to pass the arguments to the function. So we are not going to pass any argument to the function, so we'll just keep it null, all right. So after that we have used the pthread underscore join function for threads, that is basically equivalent of wait function for the processes, okay. So a call to pthread join basically blocks the calling thread until the thread with identifier equal to the first argument terminates, okay. So now what we're going to do is that we're going to compile it. So compiling this program is a little bit different than the regular C program. So with press Ctrl Alt T, we would open up our terminal, and inside our terminal what we're going to do is that we're going to write here gcc, and then we're going to write here the name of the file, which is essentially thread.c, but it resides on our desktop. So first of all, we'd move to our desktop, and now I'm gonna write here gcc and the file name, which is essentially thread.c, and then in normal cases we write here -o or -o, and then we write here the output file name. But in this case we're just gonna write here negative or -lp thread, okay. So we write this and then we hit enter, okay. So when we hit enter, you can see that there are no errors here, And if we go to our desktop, you can see that we have another file created, which is a.out. Okay, previously it wasn't there. So now what we have to do is that we have to go to our terminal, and in here we need to run this a file. Okay, a.out. All right, so now we hit enter. You can see that here we have before using threading, and then it has printed out we are using threading, and then it has printed out after thread. Okay, so that was a simple program in which we have used threading. Okay, and it has taken a sort of a pause here because of the pthread join function. Okay, so now what we are going to do is that we are going to write a simple C program in which we would show multiple threads with the use of static and global variables as well. Okay, so let's go ahead and let's try to do that. All right, so we'll just keep everything same here. I would use this same function, or you can say same file. And in this file, basically it is the multi-threading file. So let's just name it as mthread.c. So we'll just basically rename it. We can rename it from the desktop where it resides. So we can go here, we can type here mthread.c. all right, we can open it up. So when we'll open it, we have here 4 libraries or 4 header files, so we'll keep them that way. Okay, so now what we are gonna do is that we also would need the function, so we'll just keep it right here. But before this function, we are going to define a global variable. So let's call this variable a, and we must initialize it. Okay, so we have put it equal to 0, and now we need this function. So what we do inside of this function, let me just remove everything. And now what I'm going to do that inside of here, let me just remove that as well. So inside this function, what I'm going to do is that I'm going to write here integer, and then I'm going to write here a pointer static, and that's going to be id. And after that, I basically put it equal to, and then I typecast it integer, and then I write here static. After I write a bracket to enclose that, and then I write here the same variable which I have here in the argument, which is essentially var. Okay, and now I put a semicolon here to end the line. Okay, and the second thing that we're gonna write here now, first of all, here we have stored the value argument which we are going to pass through the thread, and now we are going to have a static variable to observe the change. Okay, so what we would do, we just simply write here static integer, and then let's name the variable as b, and then we can actually initialize it as 0 as well. Okay, so after writing this static variable, so now what we are going to do is that we are going to change the static and global variables. So let's say we want to change the static variable to 7, and let's say we want to change the global variable to 7 as well. Okay, so now after making this change, we'll basically print out the static and global variables. All right, so we'll just write here inside the double quote, we write here %d, and obviously the ID of the thread is represented by this ID variable. Okay, and then we're gonna do the same thing for the other variable, which is a static variable and a global variable. So we'll do that for both of them. Okay, so we'll just go ahead, and instead of having here static ID, would have here a, and would have here b, and after that we can basically change that. We can call it a static variable, so we can say the value of static variable, and here we can write here the value of global variable is okay. So now we are pretty much done creating this function. The next thing that we have to do is, after printing the argument and the static and global variables, now we are going to go inside the main function. Okay, so inside the main function, first of all, I'm going to create the thread ID using the same data type previously as we have used, which is essentially pthread_t, and we create the variable ID, or let's call it thread or thid. Okay, and we put a semicolon here, and after that what we're going to do is that we are going to have a for loop or while loop. It totally depends upon you that how you're going to create a thread. So the idea is that previously we just created one thread, so now we are going to create multiple threads. We are going to use the same function, which is essentially pthread_create. The only difference that it's going to have is that you're going to use a for loop, and inside that for loop you would call that pthread create function. What's going to happen is that how many times, it depends upon you totally, that how many times you want to run the loop or how many threads you want to create. So let's say if you run your loop 10 times, you'd be able to create 10 threads. Okay, so that's pretty much multiple threading. Okay, so now what we are going to do is that we are going to go here and we're going to have a for loop here. Inside this for loop we'll have an integer variable I, which we're going to put equal to 0, and then after that we're going to have here I, which is less than 9, and after that we're going to write here I plus plus. Okay, so once we've done that, now we are just going to have here brackets. Okay, and once we have brackets here, inside of these brackets we are just going to write here one line. Okay, so actually even if we don't have this bracket, that would be okay as well. So now we are just going to write here the same function that we have written previously, which is essentially pthread_create, and in here I'm going to write here and then I'm going to write here th_id, okay, which is essentially a thread ID, and then I'm going to write here null. All right, and then I'm going to write here the function name, which is essentially func. We put a comma here, and then we basically pass the value or the argument to the function, and that's going to be of the void type, so we typecast it, and after that we write here and then we're going to write here th_id. All right, so that was pretty much it. So we just write here a semicolon, and after that we come here, we come down the for loop, and here we want to exit it. Okay, so we just use the pthread method, which is exit, and inside of that we pass a value null, and finally we basically return 0 or exit 0. It totally depends upon you that what you actually do. Okay, so now you can see that as I have told you that all threads, they basically share a data segment. All right, so global and static variables, they both are stored in data segments. All right, so you can say that they are shared by all threads. Okay, so now let's go ahead and let's try to run this example, and let's see that what is the result that we get. So we're gonna save it, and running it is pretty much the same way as we have run the previous example. So we're just gonna clear it, and we're gonna have here gcc thread.c. We have changed the file name to mthread.c. So now we hit enter, and you can see that there are no errors. So we just essentially go ahead and run this a dot out file. Okay, so when we run it, you can see that we have run the value actually I think we have run it like 9 times, so that's why it is like, you know, showing a lot of stuff. So what we can do is that we can actually run it just for once in order to see that what's happening. And also we can write here /un so that it is like on separate lines and it is like clear. All right, so we'll just do that. So now we save it, we go back, let me just clear it, we run it, no errors. Now we run the binary file, we hit enter, and you can see that it says the ID of thread is 10953000864, and the value of static variable is 7, and the value of global variable is 7. So we can have multiple you know, values here. So what we can do is that we can run this loop until, let's say, 4 times. Okay, so we save it, we go back here, we try to run our program again, and this time we write here a dot out, and you can see that we have the same thread IDs, right? The ID of thread is -82 41 70 752, and we have the value of static variable, which is 7, and global variable, it is 7 as well. Okay, so now this is the way to basically create multiple threading. Okay, so that here one thing that you need to know, that this example is showing that how multi-threading works. Okay, you basically run that thread. Okay, so accessing a global variable in a thread is basically, it's generally a bad idea, you can say. And what if thread 2 has priority over thread 1, or maybe thread 3 have priority over thread 1, and basically thread 1 needs to change the variable. In actual practice, if it is required to access global variable by multiple threads, then they should be accessed using a mutex, which is for another day, another topic. So that's how you work with multi-threading. And one thing, every other thing I have explained to you in the previous example, except this one. So if we talk about pthread exit, this is a function that is used to explicitly exit a thread. Okay, so typically the pthread exit, basically they are you know, called after the thread has completed its work, and basically you do not need the thread any longer. So for example, if I would not have written it here, then in that case the thread wouldn't have ended. Okay, so I hope you have got the idea. Okay, so now let's go ahead and let's do a more practical example related to multi-threading. Okay, so now what we would do, we'll just go ahead and we'll just remove everything from here, or not actually everything, we might need a few of things. Okay, so what we're gonna do is that, first of all, let me just get rid of all of that. So now let's do another more practical example related to multi-threading. Okay, so in this example, most of the things you would know I have explained to you. If you don't understand anything, just ask us in the comments below. Okay, so now let's talk about those mutex. So doing multiple operations on one target, as I have told you, at the same time, it's very dangerous. Okay, so the best example that I can give you is of, you know, for databases. Okay, so if 3 threads want to write a single file at the same time, it would be a problem, because a hard drive cannot go as fast as a CPU does, right? So in this case, what we're going to do is that we are going to lock the other threads in order to not overload the hard drive with the tasks that can basically corrupt the file. Okay, so mutex, they can be used to lock the other threads In practice, what we do that we use mutex to tell if the task is logged or unlocked, and that's what pretty much we're gonna do here as well. Okay, so first of all, we're gonna have here hash include, and then we're gonna have here stdio.h. Okay, and then we're gonna have here hash include, and then we're gonna write here uni.std.h. Okay, and these are the pretty much the same header or files that we have used previously, right? And finally, the most important one that we're gonna have here, that is essentially pthread.h. Okay, so now what we're gonna do is that we're gonna use a data type called as pthread mutex underscore t. So we just write here pthread underscore mutex underscore t, and we call this, let's say, locked. Okay, so we call it locked, and then we write here an integer variable a, let's say, and then after that what we're gonna do is that we're gonna have a void process. So we just write here void, and then let's call it process function, and in here what we're gonna do is that we're gonna write here pthread underscore mutex underscore lock, and in here we're gonna write point towards it with the ampersand sign, the locked that we have created. Okay, up there. From here, let me show you this one. Okay, so this one we have pointed towards it. So now what we're gonna do is that we are going to have a variable here, essentially let's call it I, because we're gonna use it inside the loop. So we'll just write here integer I equals 0, and let me increment the a plus plus, and after that we're gonna write here while loop, while, and we put I is equal to or less than 5. Okay, we can basically indent the code here. So now we're gonna write here I less than equal to 6, and then after that inside the while loop we're gonna have a body of while loop first. So just write here the body of the while loop, and inside the while loop we're gonna write here print f, and in here we're gonna write here percentage d, and obviously that's gonna be a. Okay, so once we do that, so now we basically put a semicolon here, we come to the next line and we sleep it for, let's say, 3 milliseconds. So you pass 3 through it, and after that we basically increment the variable I. We're gonna keep incrementing it because after 6 this loop will be broken. Okay, so we need something to get the loop going. Alright, so once we've done that, we can come outside the loop and we can say that the loop is finished. So we can just write here printf, and we can say finished. Alright, so we know that the loop has finished, and now the other thread is allowed to go ahead and, you know, do its thing. So now once we have done it, now we want to unlock the thread. So we're gonna write here mutex underscore unlock, and we're gonna pass it the variable or the thing that we have locked. Okay, so now we put a semicolon here, we are all done. So once we have written this function, now we are going to write here the main function, or the main block you can say. And inside main block, what we would do would have here, let me just go ahead and write here integer variable, and this integer variable would have a name error, and then we're gonna create two threads here, pthread underscore t, and then let's call it th1, and the other one let's call it th2. Okay, and after that we come down here, we write here if, and then inside this if statement we're gonna write a condition, pthread underscore mutex underscore init, and we're gonna have brackets here. So inside these brackets we are going to pass a function here, or excuse me, we are going to pass here the variable which is essentially locked. It was, I think it is a global variable. Okay, so it can be accessed in this function, and it can also be accessed in the main function as well. So we write that, and then we basically pass the other variable as null, and then we check it. If that is not equal to 0, then we basically want to print out that mutex initialization was failed. Okay, so we'll just print out here that mutex wasn't created successfully. So we'll just write here mutex wasn't created successfully. Okay, so, or you can say that mutex creation was unsuccessful. That's more decent, right? Was unsuccessful. All right, so now we put a semicolon here. Once we have done that, what we want to do is that now we want to return something. So let's say we return 1 here, because it was so now the mutex creation was unsuccessful, so we don't want the program to run anymore. So we'll just write here exit 0 or exit 1, it really doesn't matter. So once we have done that, now would basically come out here, and we had a global variable a which we have used, so we just put it equal to 0. Okay, we reinitialize that, and now we are going to create two threads essentially. Okay, so the number 1 thread is going to be th1 that we have created, and the number 2 thread is going to be th2. Okay, so what we're going to do is that we are going to write here p thread underscore create, and then we're going to have brackets here, and then we're going to write here th1, and after that we're going to put a comma here, we're going to write here null, and then we're going to write here the function name essentially, and I think the function name is prox function. Okay, so we'll just basically copy it and make sure that the name of the function is like, you know, you have written it in case sensitive thing, because C is case sensitive, and if you have a little bit of spelling mistake or a spell mistake, obviously it is going to throw you an error. Okay, so I hope you've got the point. So now what I'm gonna do is that I'm gonna write here null as well, because I don't want to pass any value through the function. So now we are done. So I'm just gonna copy this line here as well, and I can write here thread 2, and after that I can have a pause for both of them, and that would be basically pthread underscore join, and then I'm gonna have brackets here, and inside these brackets I'm gonna pass the threads. Okay, so I'll just write here th1, and now I'll write here null. Okay, so this and sign, it's basically kind of a pointer, and this is the exact variable that you're writing. Okay, so you're writing it directly. So you write here a semicolon, and now basically you need to write the same thing here, so you just paste it right away. So with the little change, and which is essentially the name of the thread. So once you have done it, till here. Now you just simply return 0 and you're all done. Okay, so that's how basically you create mutex. Okay, so yeah, that is it. So that is your whole code. So now what you're gonna do, that is your assignment, that you're just going to write this code here, and then you're finally gonna go and you're gonna run it, and you're gonna let me know in the comments that what is the output that you have got, and show some interest in the comments. And if you have any errors or something like that, discuss that in the comments below. We'll get back to you as soon as possible. And for such free videos and free content, subscribe to our YouTube channel and hit the bell icon. Thank you so much for watching, and I'll see you in another video.